Our objective for today is to use trigonometric ratios, right? So trig ratios to find angle measures in right triangles and to solve real world problems. Okay, so let me give you just a short tutorial of what we're going to talk about today. So last time we talked about stuff like this, where we had maybe some right triangle here, where maybe we knew that this was, I don't know, maybe 32 degrees, okay? We knew that maybe this was 14, and we want to know this, right? So since we're using the opposite side of the angle that we know, and we're trying to figure out the hypotenuse, right? We'd say the sine of 32 degrees equals opposite over hypotenuse, which would equal 14 over x, right? And then we'd end up solving, you know, using some algebra skills and some division, okay? Well, today, what's going to happen is a little bit different, okay? So we'll be given, you know, some right triangle here, you know, like this, and maybe we'll be given, let's say this side is, I don't know, let's call it 6, and this side is 4, right? And they'll say, what's this angle, okay? And so what we learned today is going to help us a little bit more with that, okay? So it's almost like we're working backwards in a sense. Maybe using inverses is a good way to put it. But that's sort of what we're looking at today, okay? Now, let's look at a little background here. So this one says San Francisco, California is really famous for its steep streets. The steepness of a road is often expressed as a percent grade, right? So they'll maybe say it's a 5% grade. Okay, well here, Filbert Street says the steepest street in San Francisco has a 31.5% grade. This means that the road rises 31.5 feet for every horizontal distance of 100 feet, okay? And so it says right here, kind of important, okay? It says this is actually equivalent to a 17.5 degree angle. All right, well, how they actually got this number of 17.5 again, is what we are going to discuss today. All right. So again, that's just a little bit of background information. In the next couple videos, we'll start going through some examples.